Are we good? Okay. So what I wanted to talk about in the vendor update today is just our recently introduced second generation AMD EPYC processors. I know the tagline that we've got there sounds pretty bold, the new standard for the modern data center. But as we kind of talk through the innovations that we've made in this product, I think that holds true. I think the innovations that we've made, when we get through talking through them, you'll find that this is really a truly innovative product, the kind of a product that you get. Like I said, for me, I've been fortunate twice in my career. I've been able to work on a product that's innovative, but most folks only get to work on a product like this once in their careers. But like I said, as we talk about, this is the second generation of the EPYC product line. That, EPYC is a pretty new brand. It's only been introduced in 2017. Also, from our GPU standpoint, we have the Radeon Instinct brand, which is only a few years old. But the important thing to know is that the engineering minds behind these devices, both the EPYC CPUs and the Radeon Instinct GPUs, they've been doing this for 15 years. So they understand the enterprise market. They understand the HPC market. These aren't folks that are just trying to take a client device and trying to put it into a data center environment. And like I said, the engineers behind these technologies have been coming up with innovative technologies for that full 15 years. So everything that's on here, these were all industry first, right? So AMD 64 was the first 64-bit x86. We were the first with direct connect architecture, the first with the Infinity Fabric that I talked about a little bit earlier today, first with 7nm server GPUs and PCI Express Gen 4 GPUs. So we've got a long history of innovation, both in our data center CPUs and our data center GPUs. And over the last couple of years, from the introduction of the first gen EPYC in 2017 to the introduction of the second gen EPYC last month, we're continuing to work with some of the leaders in the HPC industry. So for some of the folks that I've talked to over the last couple of days that are looking at doing HPC in the cloud, we've got instances available for Microsoft Azure as well as Oracle that are optimized for HPC. We also have a large number of instances available for AWS. Folks that are doing more traditional deployment models, we've got a design win with HLRS that was announced last year at Supercomputing with NERSC that'll be deployed in 2020 using a future generation of AMD EPYC processors, as well as significant wins with NICF in Europe as part of the team that works with CERN. And then more recently, Indiana University came out and announced that they're going to use the second gen EPYC products. ARL announced that they're going to use them. The Air Force announced that they're going to use them. So over the last several months, a growing number of customers have come out and publicly talked about their plans to use second generation or even third or fourth generation EPYC processors. And one of those systems that's going to be using the future generation of EPYC technologies is the Frontier supercomputer. We've talked about it several times throughout the last couple days, but this is going to use a future generation of AMD EPYC processors and a future generation of the Radeon Instinct GPUs, and they'll have a new version of that Infinity Fabric that I talked about earlier that'll coherently connect the CPUs and the GPUs in the Frontier system. So this is going to be 7x the performance of the Summit supercomputer, and like I said, we're on track to deliver this system to our partners, again with a future generation of EPYC and Radeon Instinct in 2021. From a roadmap standpoint, again on the EPYC standpoint, we just introduced the second generation EPYC, sometimes also called the EPYC 7002 series. That was introduced in August of this year, so that'll be kind of the focus of my talk. But we are on track to develop the third generation EPYC, which we're calling Milan. That is still on track, and from a Radeon Instinct standpoint, the most recently introduced product we call MI50, it was introduced late last year, and we're on track for the MI next. So continuing to innovate on both the EPYC and the Radeon Instinct roadmaps to build that road to the Frontier supercomputer. One of the big differences between the first generation EPYC and the second generation EPYC is the advances that we made in the floating point unit, and that has really opened up the market that we can successfully address with these products. So that first gen EPYC was really optimized around memory bound codes. So things in manufacturing, oil and gas and weather were areas where we really shined, and DLR is one of the customers that most recently announced that they were using the first gen of EPYC for a lot of the aerospace research. But with the second gen EPYC, again, we quadrupled the floating point resources per processor, so double the floating point per core and double double the cores per processor, and that really opened up the spectrum of workloads that we can address. So giving us leading performance in life sciences workload and giving us a really balanced architecture from a flops, a memory bandwidth, and I/O bandwidth and latency to address a lot of these big university and government supercomputers that we kind of talked about a little bit earlier. So the 7002 series processor, this used to be called Rome for those of you that have been following AMD's roadmap. We talked about the Rome code name for quite some time. It's now like I said, the second gen AMD EPYC, or the EPYC 7002 series, and we really believe it delivers a leadership architecture which enables leadership system performance and delivers leadership security for the next generation of enterprise and HPC systems. One of the technologies that we use to build these devices is 7 nanometer process technology. So this is the first x86 processor that's been built in 7 nanometer technology. This allows us to have significant performance and performance per watt gains over the prior generation. Again, so kind of depending on how you want to do it, whether you want to use this technology in some of our laptop products or in our data center products, you can either get the same performance at half the power, or double the density if you want to go for the kind of performance metrics that we're looking for from an HPC standpoint. Showed this chart a little bit earlier from a Infinity architecture evolution standpoint, but again, just wanted to stress how this architecture has evolved from the first gen to the second gen, with Infinity Fabric connecting the dedicated CPU die and the I/O and memory die. This new architecture, again, this is the first of its kind in the server industry. I really believe that 5 to 10 years from now, all server CPUs are going to be built this way. But by optimizing the processes, again, we're able to get much higher core density on the CPUs by building those out of the 7 nanometer process, and great efficiency out of the I/O die by having all of the I/O on one centralized die there. So it's got the Infinity Fabric links that go socket to socket. It's got the PCI Express links and the memory controller all on that one 14 nanometer die. It really gives us a much more balanced architecture than the first generation solution. And so some of the advantages of PCI Express Gen 4, again with that chiplet or Infinity architecture design, we're able to bring the first x86 processor with PCI Express Gen 4 to the market. And so for customers that are looking for NVMe performance, on the panel we just talked about EDSSF and getting high performance storage. So the highest performance NVMe drives are going to work best with AMD EPYC processors, as well as the highest performance connectivity. So whether you're looking at Broadcom or Mellanox for high performance low latency interconnect, we're going to have superior interconnects there, or accelerators if you're looking for the Radeon Instinct accelerators that I talked about, or the Xilinx FPGAs that all have PCI Express Gen 4 today. Again, we believe that this is the best host processor for next gen accelerators, next gen I/O, and next gen storage. So kind of the product specs. So up to 64 cores. Each of those cores has SMT, so 2 threads per core, so 128 threads. The way that the Infinity architecture has been designed, like we talked a little bit earlier, you can use all of the Infinity architecture links for PCI Express if you so choose. So up to 128 PCI Express lanes, up to 225 watts, and up to 3.4 gigahertz boost frequencies in our highest performance processor. So how that kind of compares to the competitor for ANSYS Fluent simulations, up to double the performance of competitive solutions for ANSYS Fluent simulations. We've got a number of performance metrics that I'm not going to go through today, but across manufacturing, across life sciences, across just kind of general HPC compute, memory bound or compute bound, we've got a large amount of performance data that, like I said, when we say that it's the new standard, it's not just based on marketing. We've got this in the hands of our engineers and our engineers at our customers to really prove out the performance and the like I said, for most people, once in a career, for me, unfortunately, twice in a career jump that you see generation to generation with this product. And like I say, We've got 80 world records right now across HPC, but also enterprise, storage, cloud computing. So all the prominent benchmarking consortia, SPEC, VMware, TPC. We've got a number of benchmarks out there from AMD and our partners, kind of, like I say, substantiating and validating that it's not just our perspective on these processors, but our customers and our system buyer partners are seeing the same level of performance. The other area, in addition to performance that I talked about earlier, is the security with the second gen EPYCs. So like I say, when we go from kind of the first gen there in the middle to the second gen, we've increased the resiliency to some of the most widely known security threats that are out there. Some of the Spectre and the speculative store bypass. We've got hardware-based mitigations for those threats, as well as unique technologies like secure root of trust technology, the ability to secure all of the memory contents through our secure memory encryption technology. You can fully encrypt memory. And then, like I say, for those of you that are using virtualization or using cloud resources, we have a secure encrypted virtualization technology that allows virtual machines to be fully encrypted as well. So kind of how EPYC stacks up for these new and emerging modern data center workloads. So we talked a little bit about double the performance of competing solutions. If you look throughout our product offering, from our most cost-effective to our highest performance parts, throughout that stack, we're providing about double the performance per dollar of competing solutions. So if a lower core count part that has higher frequencies, ideal for your workloads. If your workloads get the best performance by kind of having a mid-bin processor that has the best memory bandwidth per core, like I said, we're going to deliver excellent price performance and the entry price points and mid-range price points, as well as in our highest performance parts. And from a performance per watt standpoint, again, up to 55% higher server performance per watt than competing solutions. Again, that's based on a server performance per watt metric, not just measuring our processors. So really significantly changing the game from a performance per watt standpoint. And like I said, finally, from an ecosystem standpoint, we've got broad availability from however you guys want to access your systems. Like if you want to access it from a cloud standpoint, from a traditional OEM standpoint, all the major OS partners, all the major IHV partners, we've been collaborating with and doing co-design of the second gen EPYC with them. So for instance, partners like Broadcom, partners like Xilinx, partners like Mellanox, we had prototype EPYC systems in their labs, and we had their equipment in our labs as we were bringing this product to market. So these have been co-validated from a hardware and software standpoint by AMD and our partners. And so finally, I kicked it off with this being the new standard for the modern data center. Hopefully you think there's some meat to that and not just marketing fluff. But like I say, with 80 world records of performance, up to double the performance per watt, and widespread availability with double the platforms available of the first gen. And again, available today. Like I say, this product launched and last month, and we've got broad spread availability from cloud computing partners as well as traditional OEMs today. Thank you much.
Thanks, Andy. Maybe time for one quick, short question.
What's your current double precision floating point operations per clock tick, and is that going to change in the future?
So right now we're at supporting AVX2, so 16 double precision, like I said, per clock per core. We do have wider vectors on our roadmap, but we're not publicly disclosing the timeline of that. But like I say, we can definitely talk about the timeline of that and the width of those vectors in a private conversation.